Hello, so today's lesson we're going to be looking at consolidation of some Year 8 shape questions. So for each slide I'm going to just show you the question, probably give you a little bit of a hint, you have a go, and then I'll go through the solutions so you can check your answers. So here's our first one. We've got angles on a straight line. So what you need to remember is all angles on a straight line add up to 180 degrees. So while you're having a go at those, pause the tape. So welcome back. Let's have a look at, question A. So if all of the angles add up to 180 degrees, and we can see we've got 35. To find A, all we need to do is to say 180, take away 35. So A is equal to 145 degrees. And with B, you should have recognized that this symbol here represents a right angle, which is 90 degrees. So we know two of the angles. So we could say 90 plus 60 is obviously 150. Just write that down just to be sure. And then 180 take away 150 is 30, so B is 30 degrees. So here's our next question. We need to remember that all angles around a point add up to 360 degrees, and the other thing we need to know is that vertically opposite angles are equal. Vertically opposite angles are equal. So have a go at those and pause the tape. Okay, welcome back. So let's have a look at question A. So we've got four angles there, three that we know and one that we don't. So our first job is to add up the ones that we know. So we've got 130, 55, and that square representing a right angle, which is 90. Let's add those up. So we've got our known angles add up to 275 degrees. And then we're just going to take that away from 360. Mine went black a little bit there. So 85. So angle C is 85 degrees. So a couple of ways we could have a look at this, right? But a good rule is to, if you've got more than one angle, is to go through them in alphabetical order. It's usually a little bit of a hint from the person who's written the question. So let's just consider this straight angle first. Straight line, sorry. So if we think back to last lesson, the last question, sorry, we had angles on a straight line add up to 180 degrees. So to find B, we would just say 180 minus 45. So D must be 135 degrees. So if you're not sure about vertically opposite angles. Right, so this angle here, 45, that we're given, and E, they are vertically opposite. And F and D are vertically opposite. So when we've got two straight lines intersecting, like that, the angles that are opposite each other are equal. So from that then, we don't need to do any more calculations. We can just see that E is vertically opposite 45. So E must be 45. And F is vertically opposite D. We already know what D is. So F must be 135 degrees. And if you wanted to double check you were right, you could add up the 45, the 135, the other 45, the other 135, and it would come to 160. So here's our next question. Angles in a straight line, angles in a triangle always add up to 180 degrees. So have a go at those and pause the tape. Welcome back. So let's have a look at A. So we're given two of the angles. We've got a 90 and a 125, not a 125, but a 25. So we add up our known angles and we get 115, and then we take that away from 180. So G must equal 65 degrees. So question B now, this symbol here lets us know that those sides are the same length. And that also tells us that the angles opposite those lines are the same. So this angle here is H also. So what we would do is we would say, well, 180 take away 40 is 140. And then that 140 represents both of those angles here. So 2H is equal to 240. So if I want to know what 1H was, not 240, don't it? Start again. 2H is 140. So if I want to know what 1H was, I would just half the 140 and get 70 degrees. Okay. Okay, so welcome back. Let's have a look at question 4 now. So while you're having a go at those, of course, the tape. So for question A, right, we're going to need to add up the ones that we know. So 80 plus 80 plus 40. So 8 and 8 is 16, and another 4 is 20. So we've got 200 degrees there. And all we do then is take that away from 360. And we end up with 160. So angle I must equal 160 degrees. So B, same thing, we're just going to add up the ones that we know. So just off the top of my head, I obviously know 90 and 90 is 180. So I'm going to add 180 to 115. So 295. All I'm going to do then is take that away from 360. So we end up with 65. So angle J must equal 65 degrees. Let's look at our next one then. So our volume of a cuboid now, our volume of a cuboid. So to do that, we need to just add the length, the width, and the height all together to give us our volume. So pause the tape. Welcome back. So let's have a look at A. So we're going to multiply 3 by 4 by 6. So 3 times 4 is 12. And then 12 times 6 is 72. So let's think about the units now. So we've got lengths in centimeters. And we're doing volume. We've multiplied 3 lengths together. So our unit for volume is centimeters cubed. So question B, we're going to say our volume is, 3 times 3 times 14, 3 times 3 being 9 times 14. So I know 10 times 14 is actually 40. So we take 14 away from 140 and get 126. Pardon me. And then we've got our length in meters. So our unit for volume must be meters cubed. So let's have a look at surface area now. So for surface area, you need to think about any cuboid or cube has got 6 sides. So we can see one here, and another one here. And obviously each one has got another, it's got like a pair on the opposite side of the shape. Okay, so have a go at those, pause the tape. Welcome back. So let's have a look at A. So I'm just going to work out what the area of each of those sides is. So I can see I must have one that is 7 times 4, which is 28. I must have one that is 7 times 2, which is 14. And I must have one that is 4 times 2, which is 8. So we're going to add those 3 up. So I've got 8 plus 8 is 16 and 4 is 20. So I've got 2 plus 2 and 1 is 50. But when we think about the fact that we've got 2 of each of these, we need to double that 50. So we're going to say 50 multiplied by 2 is obviously 100. And we've got lengths in meters, so our total surface area must be meters squared. Okay, so this next one, since it's a cube, we've got 6 identical faces. So slightly easier. Just need to think, well, the area of one of those surfaces is 3 times 3, which is 9. And then thinking of the fact that we've got 6 of those, just say 6 times 9 is 54. And we've got lengths in millimeters, so the area is millimeters squared. So our last one now, area and circumference of a circle. So area is pi r squared, or pi times r, and then circumference is pi times d, pi times the diameter. So a diameter is a line that goes from one side to the other, passing through the center, and our radius is a line going from the center to the side. And obviously a radius is half the size of the diameter. Okay, so let's have a look at question A. So assuming we're using a calculator, so all you're going to say is for A, our area, we've got pi times the radius, so that must be half of the diameter, so we've got 4 times 4, or 4 squared, so that is pi times 16. We put that into our calculator. And to 2 decimal places, we'll have 50.27. Looking at our units, we've got lengths in meters, so we've got our area in meters squared. And then our circumference, we're just going to say it's pi times the diameter. So we've got pi times 8. Which we're going to do 2 decimal places again, which is 25.13. 25.13 meters. Right, so let's have a look at B. Same thing, we've got area is equal to pi times 3.5 squared. So using my calculator, I get an answer to 2 decimal places of 38.48. And we've got lengths in centimeters, so our area is centimeters squared. And then for volume, we've got pi times the diameter, so that's 2 radius, so 2 times 3.5 is obviously 7. So let's work that out. A calculator, I've got, again to 2 decimal places, 22.00 centimeters. Okay, so that's the end of that. Thank you very much, and I will speak to you soon.